Hello everyone and welcome. This is the video for section 1.5b, modeling with linear functions, and in this particular lesson we are going to focus on using technology to find the line of best fit. So we will be completely dependent on technology today, specifically Desmos, and I misspelled it in your notes. Let's fix that right now. Specifically Desmos, Tennessee. It should be linked in your Google Classroom for you to click. If you don't have a link, you can just simply search Google and put keywords Desmos and Tennessee, and it'll bring you straight to it. So the reason why we're dependent on technology is because real world data is very rarely perfect. So let me tell you what I'm talking about. So if you were going to look at a lot of different scatter plots right here. So let's say over here I've got a perfectly positive linear relationship. See how all the lines are perfectly in a straight line? Well, that means that I have a very strong correlation coefficient. And don't worry about it. You don't have to find that. The Desmos will find it for you. Now, what if it's not positive? What if it's perfectly negative? That means your correlation coefficient would be -1. Now, look what happens when it gets a little bit less like perfect. So it's a little bit more spread out, but you can clearly see that you've got this negative relationship here. And then let's say it gets a little bit more spread out. So that's kind of like a moderate relationship, but it's still negative. This one's still negative, but look at how spread out all of those points are. And then you eventually get to a correlation of 0. That means it has absolutely no relationship at all. So that would be a terrible, terrible equation to use. Now let's go back over here to our perfect positive and make it a little bit weaker. You can still see that it's a positive relationship and it's very close to 1. Same here, it's a little bit more spread out, it's close to 1, but see how the coefficient gets closer to 0? And then the weaker it becomes, the closer to 0 it is. This one's 0.3, but notice all of these numbers are positive. So 0 is the worst it could possibly be, and then 1 is the most perfect it could possibly be. Negative side, 0 is the worst it could possibly be. -1 is the best it could possibly be. So the closer to +1 or -1 it gets, the better the model will be. So I keep talking about linear regression and a model and all that good stuff. Well, what's going on? So basically what happens is you're going to type in all of your data into a table on Desmos, and then you're going to code it. And I'm going to tell you what the code is in a minute, but it's basically like slope-intercept form. So after you type in your code in, then you can find your slope and your intercept, and then you can, if you have a good correlation, then you can use it to predict data. Something I do want you to highlight though, make sure that your line of fit, you've got to make sure that you understand that the line of best fit is an estimate, okay? This is not perfect. Unless your correlation coefficient is exactly 1, then it's going to be an estimate of the data. So they are estimating. So on your notes, I've got the same kind of scale right here. You can see that 1 is a perfect relationship, but it is on the positive side, and -1 is perfect, but it is on the negative side. Anything kind of in this like squiggly zone right here is not a really good model or an equation for you to use. So you would want to use something that has a correlation coefficient that's hanging out in the yellow zones. So those are good. So it's going to have a moderate to very strong to perfect relationship here between 0.6 and 1. And likewise over here with the negatives, it's going to have to be between -0.6 and -1 if it's negative. All right, let's get into the actual steps of using Desmos. We've got 4 basic steps here. The first thing you're going to want to do is you're going to want to add a table, and I've got a picture here, and I'm going to show you here in a second. But all you have to do is click on this plus sign and then choose table, and then you're going to have to enter the table and the data into the table yourself. Now, in the second line, what you're going to do is you're going to type in the linear regression code. Now, do you see how it looks very much like slope-intercept form? So there's 2 big differences. You have a 1 next to your y and a 1 next to your x. And the reason why you have 1s here is because it's going to match your table values. So if you scoot up on Desmos and you look at your table, the table should say x1, y1. The only difference right here is a tilde. So instead of equals, you're going to use tilde. It tells the computer to estimate. So if you try to type in this code using an equal sign, it's going to give you an error. Once you do that, it's going to pop up something that looks similar to this. It's going to give you statistics. It's going to give you R squared. We don't care about that. We study that in senior statistics. But this right here is your correlation coefficient. We just talked about that. So the closer it is to +1 or -1, the better it is. Now this is negative, which means that you're going to have a decrease. If you look at your scatter plot, I'll show you how to do that in a second. But this is pretty darn close to -0.1. I'm sorry, -1. So this is a very, very good model. So we're going to use that to predict things if it asks us to. And the other two things that we need to see are our slope and our intercept. And we found that by hand the day before or in the previous lesson. So if you have all the data, like if you have a scatter plot of data, you can just use technology to find your line of best fit instead of having to do it by hand. And you're going to do the same thing you did by hand. You're going to substitute M and B into the slope intercept form. If it is a good fit and then this one happens to be a good fit, you can say yes or no. Is the model useful? Yes, it is. And if it is, use the line of best fit to make predictions. All right, let's go ahead and get into it. Example 1 says use technology to find an equation of the line of best fit for the data in the table. So I'm just going to go ahead and search for Desmos. And I'm going to show you how to type all of this data in and enter the code and interpret that information. So give me just a second, and you need to go ahead and try to do this as well. The more you practice this, the easier it is for you to remember it later on. All right, I've got Desmos up. So first thing I'm going to do is I'm going to click the plus sign, and I'm going to access the table. And you see how it pops up X1 and Y1? All right, I'm going to go ahead and type in this data and then restart the video. So go ahead and pause it. You type it in also. Okay, so I've got everything in the table typed in. This is a really big table. So I'm gonna scoot down here to the second line and we're gonna type in our code. So our code is just like slope intercept form, except for I have a 1 next to the Y. And then I'm gonna hit Shift and I'm gonna access the tilde. It's the button to the left of the number 1. And then you're gonna do M, which is your slope, X1 plus B. So remember, the reason why we do the Y1 and the X1 is so it can access the data in your table that you typed in. So just make sure that your data in your table matches the numbers in your code. So here's what we're going to do. I'm going to take a little screenshot of this. We only care about R, which is our correlation coefficient, and then M and B. All right, this is what we're looking for. We are looking for the slope and we are looking for the intercept to create a line of best fit. So on our line of best fit, I'm going to round the slope to 1 decimal place, 2.6x, and then we're going to round this to the nearest whole number, which is 65. Now, the second part says estimate the height of a person. Should I use this model? So this is the question here. My correlation coefficient. If it's really close to 1 or if it's really close to -1, then that means it's going to be a really good model. This one is very close to +1, so it's a good model. That means I can use it to estimate things. All right, so we didn't really discuss it before, but let's talk about what your Y and your X stand for. If you look at the table, it shows that there's a relationship between femur length and how tall you are, which is your height. And if you don't know, your femur is that really big bone in your leg. It's the biggest bone in your body. So I'm going to go ahead and write height above the Y and femur above the X, and those are both in centimeters. So let's take a look at what they want me to do. So they want us to estimate the height of a person whose femur is 35 centimeters long. So if we're looking for the height And we know that the femur is 35 centimeters. That means that X is going to wind up being 35. And we can just type that into our calculator and see what we get for Y. So we wind up with 975. Sorry, I lied. It's not 975. It's 156. Okay, so that's 156 centimeters. Now, I'm going to show you something neat on Desmos really quick. So Desmos has this feature that it'll actually fit your data into that viewing screen right here. Notice you don't see any dots or anything. At the bottom of your table, see this little magnifying glass? It's like Zoom Fit. Click it and look and see what you got. So you can hide your line of best fit, and now you can actually see the results of that. So it makes sense for your correlation coefficient to be 0.9 because it's almost perfect data. All right, let's look at question 2. We've got fruit in a smoothie, so many ounces, and then it's going to cost kind of depending on how much fruit you have in your smoothie. So what we're going to do is check to see if it has a linear relationship. So the easiest thing for you to do is go to Desmos and click that plus sign and enter all of this data in as a table. And I'm going to do that right now. And if you want to, you can go ahead and just leave that second line alone and just kind of go back and delete. That way you don't have to start a new table. If you do exit out and you already have a table up, if you click on another table, look what happens. It makes X2, Y2. So just make sure that your table at the top does have X1 and Y1 on it. So the first thing we want to do is just double check and make sure that it's linear. So I'm going to click on my little Zoom Fit button, and where is it? Oh, okay. So Zoom Fit, you see what happened? Sometimes the Zoom Fit works, sometimes it doesn't. So I'm gonna adjust it a little bit. Here we go. Now, to me, that it's not perfect, but it's pretty darn straight. So I do believe that's going to have a positive correlation coefficient. And then I'm going to type in my code again, Y1 tilde M X1 plus B. And then you can kind of see that line of best fit, how it fits in right there. And I'm going to drag this down, and I'm going to copy this over to the notes. I only care about R, which is very close to 1, so this is a good model to estimate, and then the slope and the intercept. All right, so first things first, we're going to answer this question. Does the data show a linear relationship? Well, I confirmed it visually on the scatter plot, and the correlation coefficient also says yes, it does. So I'm going to go ahead and write the equation of best fit by rounding this to the nearest tenth, so it'll be 0.5x. And then B, I can't round this one to the nearest whole number because look at this data here. I've got 0.865, so I'm just going to do 0.865. Sometimes it just takes a judgment call, so if the number's really small, just make sure you don't round it too much. All right, let's go ahead and write down what each variable stands for. So the Y is the cost, and X is the amount of fruit. They want us to figure out the cost of a smoothie that is made using 8 ounces of fruit. So I have 8 ounces of fruit. I'm going to place an 8 where the X is. And I'm just going to type this in my calculator, and it should give me the cost. All right, so another good reason not to round is that this is cost, and cost is going to have 2 decimal places, so I'm going to round this to about $4.87. Okay, perfect. So just let me know if you've got any questions at all. Just make sure that you practice all 4 of these, and honors, you have to make sure that you are going to turn these in separately. Y'all have a great day.